All right. Round two. No, it's not. Starting at number 9 because we left off at number 8. Last time we reviewed numbers 1 through 8 were the first half of our semester, which, ironically enough, came all from Chapter 3. Chapter 4 and one lesson from Chapter 5 are on the second half. So, this is all, it's kind of a split. Some of it is more difficult, but also it's more recent, so we might remember it better. We'll see. Classify by number of terms. Anyone have the slightest clue what that meant? The something nomials, yes. We have monomials. The prefix mon or mono, bi, tri, and poly all went with nomial. And they were if I had 1, 2, 3, or 4 plus terms. Question is, what's a term? Yeah. Yeah. Terms are anything that's split up by a plus or a minus. So since there's 3 terms up there, I'll say it's a trinomial. But the second part, state its degree. Its degree, we look at the exponents. This has an exponent of 2. This has an exponent of 4. This has an exponent of 3. The degree of the entire term, or the entire expression, was the big dog. You always choose the big dog. Who's the alpha of the group? Who's the one that decides what movie you're watching? Okay.
Yes.
So, just like last time, I do some, you do some. Do it again. Classified by its number of terms, state its degree. This one's got, you're going to see this throughout today, is the second one might have just a little dash of spice on it, a little bit different. Every time you run into a plus or a minus, chop it up, Fruit Ninja style. Okay. Every time you run into a plus or minus, chop it up. We're getting there. There are 4 terms, so what do I call it? Polynomial. P-O-L-Y. Poly. I remember those.
I loved those things.
What were those?
Polly Pockets.
Polly Pocket was a choking hazard, is what it was.
Like they
It was this itty bitty little person in a little like locket-looking dollhouse or something, or
and it was like these rubber
yeah,
clothes and rubber shoes. I loved that.
yeah.
Loved them.
It was itty bitty. It was like a little dollhouse or a little play set in the size of like a earbuds container. They were itty bitty. Yeah. Okay. How do I deal with the degree on it though? When, well, I know this is a 3. I know this is a 2. What's this? Wise.
Because there's an invisible for zero.
Remember, anything to the 0 power is 1. If it's 4 times nothing, there has to at least be a 1 there. And anything to the 0 power makes 1. So this one actually has a degree of 0 back here. And, Tava, you called it. There's a little invisible 1 right there. So when I look at the degree of each individual term, I have to count up all the exponents.
I remember this.
I just have to look back at my notes.
Every time we do this, I want you to make a note to yourself. If you goof something, put a note right next to that problem and tell yourself, if there's more than one variable, add the exponents for each term. Tell yourself that. Because you get to tell yourself how to do the test. Real adults look things up. Just a couple hours ago, I was doing a geometric sequence series with pre-calc. I just blanked. I just had a brain fart and I forgot what the middle formula was. I looked it up. I wrote it down. Now that I got it written down, now I know what to do. That's what a functional adult person does, is you look things up. You still have to do the skill. Okay, so that one is degree 4. Next, simplifying expressions by adding or subtracting polynomials. See, if I add them, it's no big deal. You just combine like terms. But if I subtract them,
You have to do the one thing.
you do the one thing. Now, are you being intentionally ambiguous, or are you saying the one, the number one?
No, like the one. You have to put the one in front of
Okay. There's a little invisible 1 right here. More appropriately, there's an invisible negative 1 there. Don't do that. So if I distribute this negative, like that, and then this stuff didn't change, so I'll just drop it. See, if I don't distribute that negative, in my experience, what happens is kids will remember to subtract the 7x squared, but then they'll subtract 16x and add 2. They'll forget that you're subtracting every one of these. So if I just distribute the negative, I don't have that problem. Chop it up. Every time I run into a plus or minus, it's a new term. And remember that to be a like term, it's got to meet 3 criteria. Number 1, they have to have the same variables. Number 2, same exponent. And 3, to be like terms, they have to have the same exponents on the same spots.
What did you say?
See, same is broken up, exponents, variable. For example, if I were to write this as that looks goofy, right? At least here you recognize same and expo. But if I wrote it like this, it's same here.
Thank you.
Now it's same POEX. You see, they're not in the correct spot to make sense. So, which of these are like terms? Do I see any other x squareds?
3x2 and -7x2.
Okay, this and this are like terms. So I'm going to say negative 4x squared. Remember, those exponents don't change when I'm combining them. I'm saying 3 things minus 7 things. Things doesn't change. And then negative 9x Positive 16x makes a positive 7x. Get rid of them. And finally, 15 minus 2 is a positive 13.
That all we have to do?
Yes. I ain't trying to hurt you. I just want to review the stuff we did this semester. Your turn.
A positive 15 is negative, right?
It's 9
But it's not times. You're adding, aren't you?
Positive, right?
Well, it depends which one's bigger.
Wait, we're adding?
What?
Wait, what if it's 0?
0.
You said we're adding.
Yeah.
And I added 2 and... Just kidding. Wrong one.
There you go. Lily, you said Tommy likes DBZ? Just take it.
Oh, okay.
We got that from the game store. It was a promotional poster.
We used to have, not for his birthday, Dragon Balls, but then the kids at the other home were at Soda, so.
Oh, bummer.
Like as soon as we're moving out, Tommy.
No, just have it.
He's like, where are you Dragon Balls?
In fact, if you guys go to the game store across from the rec center, I think he still has some of the free promo packs of this game that they just give out to people.
Okay, I'll check. Yeah, because there's a bunch of CDs and a bunch of games on this.
Oh. Okay, it looks a lot more complicated than it is, right? That whole m to the fourth, n to the second business. If I told you that this is just 2 triangles plus 3 squares plus negative 3 triangles plus 2 squares, right? Like triangles with triangles, squares with squares. So when this says plus, I don't have to go distributing a negative. I don't have to worry about it at all. In fact, because I can do this and you can't, neener, neener. When I add a negative, it really is just subtract the thing, right? When you add a negative 3m something, it's just that thing. Okay? I only have to worry about subtracting every one of the terms if there is a subtraction sign between them. There wasn't. So you combine like terms and say 2 big monsters minus 3 big monsters is negative 1 big monster. 3 big monsters minus 2 big monsters is 1 big monster. But I don't want to put that 1 if I'm trying to simplify, because I've got other stuff to hold its place. The exponents do not change when you add. They change when you multiply. We okay with it, or we need to practice more of it? Okay. All right. Multiplying binomials. If I remember right, most of you hated the Punnett square method. Just, we're all kind of shell-shocked from biology. You were more about the arrows. Oh, that too. We say 8x by 3x. 24x squared. And an 8x times a 5 is a 40x. But because there was 2 terms in front of it, like we all remember if I said 8 by 3x plus 5, or 8x by. That's easy, right? I just distribute. Well, these ones we had to distribute twice because there were two terms with it. Since there was two terms in the first binomial, I have to distribute twice. Just watch your signs. And then, before I can call it done, are any of those like terms?
Yes. 40x minus 9x.
And that's 31x. Okay. Most of us were about this arrow thing. The alternative, remember this? Where you could have put 8x and negative 3, 3x and 5. I mean, it's still going to end up the same.
Just in different ways.
Yep. Some people prefer that visual organization, some don't. Get them. Okay, distribute twice. Look for your like terms. In the way these are set up, they'll usually be the middle ones. Combine like terms.
You can also take it down further.
No, you can't. No, you can't.
Never mind, actually. I was about to say you could take it further by dividing all by 4, and then realizing, no, you have to take x as well.
Now, what you're thinking is the greatest common factor. Now, you could do this. Words, 12. But here's something that you might not think of. That is not simplified. Because there's parentheses. If there's parentheses, it implies that there's another operation. This line says, I just need to add things. This line says, I need to add things and multiply by 4. Because this line says, do more things, it's not simplified. And kids usually get to this stage towards the end of algebra when they've done factoring, is they think they have to factor everything. No. Don't factor it out. Just leave it like that. That is simplified. That's as good as it gets. There's reasons to factor, but it's not simplified form. All right. This is one of the two things that I'd say is probably maybe the toughest or the longest of what we did this semester. And it's more because I've just got a lot of moving parts. Do we remember Exploding everything outward. Yup. What times what makes 80?
8 and 10.
I heard 8 and 10. What by what makes 8?
4 and 2. And then 2 is 5.
Okay. Does everyone have their multiplication chart on hand?
No, but I can actually remember.
No, I'm good.
Multiplication charts or calculators. What by what can make a 48? Okay. Yep, you break them all the way down. And then since we already saw 8, we know this. What about 32? What if I said 2 and 16 instead of 4 and 8?
It would just go down to 8 and 2.
At the end, I will still have 5 2s at the end of the branch, whether I go 4 and 8 or 2 and 16. That's the cool thing about prime factorization is as long as you take it all the way to the end of the branches, they should all look the same. No, they will look the same. That's the definition of prime factorization. So the first one, I've got a 2, a 2, a 2, a 2, 5. And then x squared, so I'll put a pair of x's and a y. Next one, I've got a 2, a 2, a 2, a 2, a 3, an x and a y. Last one, it said minus here, so I'll just put a minus here. We've got a 2, a 2, a 2, a 2, x, and a pair of y's because it's y squared. What was the purpose of exploding these out like this into all their itty bitty little parts?
You can see it.
And what are we looking for? Not just pairs, whatever they have in common. They might have pairs of things, they might have 5 things, they might have nothing. I see
4 2s, an x and a y. 3 2.
I see a quadruple 2 in common on all of them. What is 2 by 2 by 2 by 2?
2 times 2.
4.
Times 2 is
16.
8 times 2 is 16. Now the fun part is after you say they've got, oh wait, it wasn't just a 16. What else they got in common? An x and a y, an x and a y, an x and a y. So a 16xy comes out. Remember, I'm dividing by these. So when I divide by all that stuff, then these are going to cancel out because they're all going to turn into ones. 1 times 1 times 1 times 1 times 1 times 1 and 1 and 1 and 1 and 1 and 1 and 1, but it's going to show me what's left. If I divide each of these terms by 16xy, I'm left with a 5x, a 3, and a minus y. Oh, did I get rid of a 2? Oh, there is. Right there. There we go. Yep, missed one.
Oh, never mind.
Because I'm tired.
I don't know how you noticed the missing 5th y, but you thought there was 3 currencies. Well, I counted and then you freaking
Excuses.
So anyway, you're going to do it again. I do some, you do some.
Our answer right there?
Yes.
Okay.
That's the nice part about them is after you explode them out, whenever you take out the common factors, you're also left with whatever goes in the parentheses. That's handy.
Bless you. You should have heard one of my scenes that we had.
Sounded like you just sneezed Wyoming State University. Hick you!
You should have heard one of my scenes that I felt. It was just a scream. Oh. I don't know that one in too. It was just a scream. She got scared.
I knew a kid who used to do that. They scream sneezed.
Well,
Like that was just how they sneezed.
I'm like an expert at scream sneezing. My sneezing is nauseous.
My dad doesn't even try to be quiet. I don't know. Sounds like my father as well.
Yep. Sometimes you just gotta let her buck.
Oh, I messed that up.
Let her know.
You caught myself messing up. I can't help it.
Boy, y'all are squirrely today. No, I'm not. I'm tired.
Or at least I think so.
Oh yeah, Andy was like screaming at me. Just get it off.
All right. When you break these apart, you should have the first one, quadruple twos for A's and a B. Next one, a 2, a 5, and oh boy, alphabet soup. And the last guy is just a 2, an A, and a B. What do they all have in common? So here's the catch. When you have a 2, an A, and a B coming out of there, you have to remember that you're dividing by that. It's not just disappearing. You are taking this divided by 2AB, divided by 2AB, divided by 2AB. So cancels, cancels, and cancels. Those are all turning into ones. 1 times 1 times 1 is just 1. But I will have left a 8, don't add them, A to the third. Over here, the 2's cancel, A's cancel, B's cancel. I still have a 5, a pair of A's, so A squared, and oh boy, lots of B's, 6 of them. Oh, yeah, it is. Why do I what? There we go. Remember, you're dividing. 2 divided by 2 is 1. A divided by A is 1. B divided by B is 1. What is 1 times 1 times 1? Don't forget that placeholder. The most common mistake that I see on these is someone forgets that placeholder because they think it just disappears. You are dividing. I cannot divide and get a 0 unless I'm dividing 0. So please make a note of that. Be careful with it. Backside. Factoring. No, it's this, and then the final is on Friday.
It's kind of funny. This is the first one that we did. Took us so long to do, and now we're just flying by this.
I wasn't here last.
But this is also recent, right? This is all from this quarter. So the closer we get to the end, the more likely we're going to see something from just last week. So It was so random. It's like Donkey saying, "I'm gonna make it waffles."
I'm sorry.
That's what I just said. Okay. So here's the deal. These, when I factor things into binomials, what I'm doing is kind of reverse distribution. Instead of this guy times that guy, I'm breaking them up. And there's a special method to it where I need to figure out what times what makes C but adds together to make B.
Oh, this yummy stuff.
Yeah, I used that.
This is a big deal for Algebra 1. Like, quadratics are the meat and potatoes of Algebra 1.
Okay, I have one question.
Yeah?
For the test like that.
Yeah.
This is gonna be on it. Yes.
Number 13 on your test looks like this.
Can I get a separate piece of paper and staple it on the back of this?
Yeah?
I could?
Yeah?
Yeah.
Okay.
Probably should be boring.
Well,
All right. In order to do this, I need to know what times what makes 84. So if I don't know off the top of my head,
hang on, I'm looking.
grab the calculator or that multiplication chart, and we're going to write them all out.
14 and 7.
How about 1 by 84?
7 and 12.
I heard a 7 and a 12.
7, 6.
6 and 14.
7 times 6 does not make 84.
14 and 6.
Oh, okay. 6 by 14.
12 and 7.
I thought she said 7 by 14.
12 and 7 is right there.
12 and 7
2 and 42.
Okay.
Oh, here we go.
4 and 21.
Grandma, that's the same
I can't write anymore. I ain't got the room.
There's 2 more.
There's 5 and 3. Oh, wait. No.
5 and 3 does not make 84.
Oh, no. I'm saying, like, we're missing. Yeah.
5 times 3 is 84.
No.
Well, if we get a little time at the end, I'll show you when you can actually add things together and say something like 2 plus 2 does indeed equal 11.
Yeah, because 1 and 1 put 11.
She's like, I'm playing bingo. Playing bingo. Yeah, because it makes them happy. So.
That's how you do it.
What?
Come on, there's still more.
3 and 28.
No, why is it part not colorful?
Oh, here we go.
It helps me find
Still
stuff better.
6 and 14.
Okay, we got the 6 and 14. Yep. No, that's it. Okay. So here's how we do this. Instead of just randomly hunting around your multiplication chart, start at 1. Divide by 1, write it. Divide by 2, write it. Divide by 3, write it. And if it doesn't work, don't write it.
Wait, what? Or just color your multiplication chart. Oh, okay.
But here's why I want to do that. I don't want to just guess and check and divide every number between 1 and 84. If I go from 1 through 7, skipping 5 because it didn't work, after 7, y'all got a calculator, you try 84 divided by 8. 8.
10.8.
Doesn't work. Try 9.
No.
Doesn't work. Try 10.
Doesn't work. Try again.
Try 11.
Nope.
And then you try 12.
Yes.
But you see how we were headed down the number trail and then we hit 12? That tells me I found them all because I'm going to start repeating things now. But I'm guessing you don't want to be trying all the numbers in between. Okay, what do I do with these?
So you put like a negative on the line and then, oh, never mind.
These are all products that make 84. Okay, so I'm going to look for, does this plus this make, nope. Does this plus this make, nope. Nope. No. No. No.
Because it's not negative.
You gotta switch them to negative.
Good golly.
Doesn't
Always know that.
a positive times a positive does make a positive 84, yes. But a negative times a negative, if I were to switch that, isn't that now a negative 19?
Yes.
Does a negative 7 with a negative 12 make a positive 84?
No.
Multiplied.
Yeah.
I'm asking.
Yes.
You have to check your signs. And a negative 7 plus a negative 12 is indeed a negative 19. So if those are the two numbers, that's the magic combination that finishes this out. If I did this right, I should now be able to do this. That's your check.
We have to check it.
You don't have to.
I like that.
But again, there's no reason you should get this wrong because you have the ability to check it. Oh wait, not that one. Get it? Yay.
Okay, guys.
Don't lie to yourself.
You want to see it? You want to see Kaden's paper? Yeah.
Kaden,
Or not.
your handwriting is literally the equivalent of an old man that's shaking.
Yeah,
It's like-
It's like if I put It's like if
Yeah, let's not mock people with a disability. Because that's a quick way to get Sparta kicked out of my room. Yeah, I'm going to line you up at the door. Down you go.
I don't think you want to that song.
So all you have to do is do 1 divided by negative 36. Or
The other way around.
1 divided by 36. Or no, 36 divided by 1. Or do I
Yeah.
have to do negative 36 divided by
Negative 36 divided by.
So my dad's on the incorrect bed.
So the 1 times negative 36. Right?
Ladies and gents, these are the factors of 36. But those aren't factors of negative 36.
You have to have 1 negative.
Well, that means I could have doubled my list, right? It could have been 4 with a negative 9. It could have been 3 with a negative 12. 2 with a negative 18. 1 with a negative 36. Like I said, please watch your signs. Which one is the magic pair? So I will write x plus 4 and x minus 9 as my binomials. Now these ones, there's a little bit of a process to it. The next ones I think you like more because they're special. But
X minus 9 and X plus 4. So that one bump.
no.
No?
Wait, say it again.
X minus 4 and X plus 4.
You said something different.
That's exactly what I just
No, you
said.
didn't. You said 9 and 4 the first time. This time you said 4 and 4. You want me to play it back for you? It's recorded.
Sure.
Say it again.
X minus 9, X plus 4.
Yes, you can do that.
Alrighty. So
Because multiplication is commutative. Remember, the order in which I multiply things does not matter.
Alrighty.
These guys are special because
OBS.
camera's right there.
You usually have your laptop though.
These ones are special because it's called a difference of squares, and they will always be a plus minus pair. Plus minus pairs are called conjugates. They're called conjugates because they go together. Any of you taken French or Spanish?
Yes.
Maybe even in English they talk about conjugating verbs.
Yeah, like no in Spanish is no.
Yeah.
Same as English.
Yeah, because
Same.
Riley,
In to conjugate means to go with. Shut your holes. Y'all are entirely too squirrely today. Knock it off. Otherwise, you can finish this off. Finals on Friday. It's nice and simple. Because it's a difference of squares, take the square root of each. What's the square root of 49? Square root of x squared. What is the square root of x squared? X. So that's what leads it off. The square root of 144 is what ends it. But it's important that you have the plus 12, then the minus 12, or minus 12 plus 12, commutative, doesn't matter. You have to be able to have both as their square roots of the original. This is a special form called difference of squares. It's called difference because I was subtracting. It's called squares because each of these was a perfect square. Now, they don't always look like that. It's entirely possible you could start with something like 50x squared minus 72. Those aren't perfect squares. But if I did my GCF business, now it is. Okay? Sometimes you have to take a GCF out before you can find that. So they're not always pretty, just sometimes.
Are they pretty on the final like that?
Try it. This one's got a little bit something different in there.
It's freaking chilly in here, dude.
I like it.
it's actually nicer for one. Plus probably because I'm maybe this one colder.
Was that the dice you were talking about? That really heavy one?
Date. I think I did it right.
Yeah, it's solid. It's 16-inch steel.
So wait, roll it on the
If I did, it would actually, it would make marks on the floor.
Would it
sofa.
dent the dice?
16 gauge.
I don't know what that means.
When you roll it over the table itself.
It won't.
It's got some meat to it. What's really fun is if I troll someone at a pre-release tournament with it, I use that as my life total. I'll say, yeah, I'll take 3 damage. And tap this, gain 1 life. I just keep doing that to mess with them. What's funnier is if you do two-headed giant with Mr. Aaron Bowerly, where you share a life total of 40. I put the other D20 on top like that.
My God.
I just keep doing that over and over through the match to just annoy the crap out of the person. So, it is a nice plus-minus pair. It is already perfect squares. But just like before, I was able to do the square root of 25 and the square root of x squared. What will I do for this one? 6y. Okay? Just be aware of it. I might come up. All right. This wasn't too long ago. To solve a quadratic biquadratic formula, first you got to be in the right form. It's called standard form. Is it? Yeah, it equals 0. You're good. Then, next to each one of these, I'm going to state that a is the number in front of x squared. B is the number in front of x. And c is the constant at the end. And then the formula, which I hope you have written down after all this time, negative b plus minus square root of b squared minus 4ac all over 2a. What did we do next before actually, plugging numbers in? Parentheses, lots of them. I want to rewrite this so I've got room for incoming numbers. Room for incoming numbers. That's why these tables are up here and I had to get rid of my big game table. I got 2 classes next year that are at 28 or 30 kids. They're big. All the classes are going to be big next year. Actually, for the next forever, but yeah. Put things in. Everywhere there was a B, I'm going to put a 12. Everywhere there was a A, I'm going to put a 2. And everywhere there was a C, I'm going to put a 10. Remember the different places that we are going to simplify this first. Here, 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 and here. We've got x is a negative 12 plus minus square root of, what's 12 squared? Minus, what is 4 by 2 by 10? 80. And 2 by 2 is 4. What is 144 minus 80? What?
Not yet.
Minus. And because these were all positive, positive times positive times positive is positive. I'm subtracting a positive number. You're thinking about when this ends up negative, then I'll have minus a negative, and it will switch. Okay. We said it was 64. I'm pretty sure that's one of my special numbers. Because the square root of 64 is just nicely an 8. So negative 12 plus 8 over 4, and negative 12 minus 8 over 4. Negative 12 plus 8 is what?
Negative 20.
No.
Oh, plus. That would be negative 4.
And then divide it by a 4.
1. Yeah, negative.
Negative 12 minus 8. You owe me 12 bucks, you borrow another 8. Now we're at negative 20, and then after I divide it by 4 is a negative 5. I really do believe that our greatest common factor stuff and our quadratic formula stuff were the longest and toughest things we did. Just because there's so many moving parts. Each step might have been not bad, but when you put it all together, boy, that's a lot going on. Your turn. Identify A, B, and C. Set up your formula. B's are negative 12s. A's are 4s. C's are negative 7. This is the one you're thinking of, Saul. Because now, those are our 4 areas. When I simplify this, we got a positive 12 plus minus. What's negative 12 squared? Positive or negative? Always positive, yep. And I'll be subtracting a number. What is 4 by negative 7? So since that's a negative 112, that's where that comes in, yes. I'll change. 144 plus 112 is? That sounds familiar. Squared root of 256 is 16. So I can now break this up into 12 plus 16 over 8 and 12 minus 16 over 8. Which are 12 plus 16 is 28 over 8. That reduces so I can either call this 7 halves or 3.5. I can call this negative 1/2 or 0.5. Negative. I'll take either. Because for these ones, we broke our rule and said we can go to decimal land. Yeah. Hey, what happens if this doesn't come out as a perfect square number?
You do that point.
Yep, we're just going to put a decimal on there. It's not going to be the exact answer, but it's going to be close. And finally, probability.
I don't like PPI.
You got a spinner. Spinner's got 12 sections on it, kind of like life. You spin the little thing and then you move your minivan full of plastic children, right? So you got a spinner with 12 sections. They're all numbered 1 through 12. Find the probability that you spin an odd number and then spin a 5.
5 is odd.
But it does say and then, meaning 2 different events. First, we got to talk about what probability is. Probability is the number of favorable outcomes over the number of total outcomes. I've got 2 different things, and what we have done so far is that if I have the probability of compound events, I take those 2 probabilities and I multiply them. So the first one, how many sections, how many total outcomes are on the spinner? How many of them are odd?
1, 3, 5, 7.
Stop guessing.
6, actually.
6. You see, as soon as you start counting out, as soon as you go back to those fingers, it's okay. Use your fingers. I'm the math teacher. I use mine. Count. 1 is odd, 3 is odd, 5 is odd, 7 is odd, 9 is odd, and 11. There are 6 odds on the spinner. It will reduce to 1/2, yes.
And then it'll be
Okay.
odd than five.
No. When I spin that odd number, does that number disappear from the spinner?
No.
These are independent. It is still 12 choices. And how many of those choices are a 5?
1.
6. There's only 1 5 in the center.
There are this many people in the room. I pick someone at random. What's the probability that I pick a Lily?
1 out of 12.
1. There's only one of her. Okay? Right? And then she's like, "That damn right there. Okay. There is only one." Okay, now multiply them. Now you can choose to reduce it beforehand if you want. I could reduce that and call that 1 out of 2, getting 1 out of 24. And what did we do with that? Because most people aren't going to understand 1 out of 24. You divide them and get the percentage. Make sure you move the decimal 2 places. And we said it was about 4%. It's going to be like 4.1 or something.
4.16.
So let's just call it about 4%. But there was a whole lot of you that were talking about, will it change the next thing? Now, Riley, keep that in mind for your jelly beans.
Which one did she slice it first?
Yeah. What did she choose first? Yeah, I'm a little confused.
She gonna take a jelly bean out, go nom 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 nom. She gonna take another jelly bean out, go nom 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 nom.
Wait, so 5 out of 10 for the first one?
Yes. But she ate that jelly bean.
4 out of 9.
There you go. Okay, yes, that is exactly it. The first time that she eats the jelly bean, there are 10 of them in the bag. How many of them are white jelly beans? Times, now how many jelly beans are in the bag? Now there's 9, because she ate one. How many of those are white? 4 of them. If I multiply those, I get 20 out of 90, which can promptly be reduced to 2 out of 9, which is about 22%. Did you take 10 divided by 5 and call it 5 because you actually subtracted it?
Wait, but what if you reduced it?
Well,
It's 2 out of 9.
I still get
8/4.
4 out of 18, which reduces to 2/9. Or I keep going, take this divided by 2 and that divided by 2, getting 2 out of 9. No matter what, it's going to be 2 out of 9. Whether you reduce along the way or reduce at the end.
I just reduced it wrong.
So, I'm going to say this again for anyone who has not paid attention. What are we doing Friday? Your final itself is on Friday. How big is it? 16 questions. We covered 16 skills. We took 16 different skills and we reviewed them over the last 2 days. I did one, you did one. That's why there's 2 pages. So your final is just a page, front and back, 16 questions. Number 7 on the final looks like number 7 we reviewed. After that, what are we doing on the 25th?
Nothing.
That is a free day or a day to get stuff done if you are not done with everything. Some of you are still missing a quiz or 2 or 8. Some of you are missing a boatload of daily work. If that is the case, then on the 25th, you get that done. What about the 28th? Remember, white 4, that is the very last scheduled final.
If you don't have anything missing or like that, you can go ahead and go.
That's right. If you have everything done, if you are 100% caught up and ready to roll, and I will let you know at the end of class on the 25th, then by my count, you're done. You earned it, go away. Why are you pointing that at me?
I'm not.
Freaking me out.
He's just slouching.
Okay.
I promise I won't be.
If, I already know I'm enough memes. I don't need to be more.
No, she's recording.
So, well, so am I.
Ooh.
Yeah, but she's gonna upload it.
Okay, just make sure that you have everything done. And if everything is done, I want you to have next week to work on your other classes, because I know a good chunk of you are probably a little sketchy in some classes and could use that time. It is not there so you can screw around. It's there so you can get your credits and then go screw around. Okay? All right. I know it's coming up at some point.